writing equations from patterns. So we've looked at our different types of patterns, linear, quadratic, and exponential. Now what we're going to do is look at a pattern and then actually create the equation that goes with that pattern. So we got a big table here with a lot of descriptions and a lot of explanations on what to do. So let's kind of pull apart the pieces here one at a time. So my linear equation, we know that the equation looks like y equals mx plus b. And what we're going to see in the output is there's a common first difference. I'll explain what that first difference means when we start to look at a table. If we see that this is the pattern of output, we're going to follow these steps to write an equation. We're going to replace m with the common difference, m in my equation. We're going to find the value of b by replacing x and y with a pair of values from the table. We've done this before for a linear. We look to find a slope, basically a rate of change, plug that rate of change in for m, and then use one of our ordered pairs to find b. We've done that before. Quadratic. We haven't found a quadratic equation though. So how does that work? Our equation is going to look like y equals ax squared, and we're going to see a common second difference. Again, I'm going to explain to what that means in a minute. And if we see this common second difference, we're going to find the value of a, it's a here, by replacing x and y with a pair of values from the table. So very similar to what we did with our linear, except there's no slope in there. And notice that the only variable besides x and y are a, so that's really the only value that we need there. We're not going to use the first common difference. That's the common difference. We're not going to use the first common difference. We're not going to use that common difference at all. All right, and then exponential. Our equation looks like this: y equals a times b to the x power. We're going to look for a common ratio. So we're multiplying that input we're multiplying by the same thing every time. We see a common ratio as opposed to a common difference. We're going to replace b with the common ratio. So our y equals a times b to the x power. B is that common ratio. And then we're going to find the value of a by replacing x and y with a pair of values from the table. So there's a lot of this replacing things with a pair of values from the table. And you may have to find one other piece. So notice here I need to find m and b. Here I just need to find a. And here I need to find a and b. So depending on how many constants you need to find there, you may have to do a few more steps. All right, so we're going to look for a pattern in each table of values to determine which model best describes the data. And then we're going to write an equation for the function that models the data. So let's take a look at our first table here. Again, I want to take a look at my x values and make sure that I'm increasing by 1 so that I can kind of follow the pattern after that. So first I'm going to look for, let's see if I have a difference or a ratio here. So here I see that I have differences, but you'll notice that my first difference is which is where I take my y values in my table and find the difference between them. So here I'm subtracting 9, subtracting 3, and then adding 3 and then adding 9. That is not a common first difference. They do not all have the same first difference. So remember here I talked about a second difference? I'm going to take the first differences and I'm going to see if they have a difference. So in order to go from negative 9 to negative 3, I have to add 6. To go from negative 3 to positive 3, I have to add 6. And to go from positive 3 to positive 9, I have to add 6 again. So when we say second difference, this is what I'm talking about here. I'm kind of extending the table a little bit further than it actually goes. So I'm finding a second difference here. So this is a common second difference because at this point I'm adding 6 each time. Common second difference is a quadratic function. So I know I've got a quadratic here. So my equation is going to look like y equals ax squared. I only need to find a here. So I'm going to use any set of numbers from my table. I tend to stay away from the zeros, but you can use those too. I'm going to use any of the values from here. So I chose to use, what did I choose? 2 and 12. I chose 2 and 12 here. So I put 12 in for my y. I put 2 in for my x. So I have 2 squared here, which is 4. So I have 12 equals a times 4. Divide both sides by 4. I come up with a equals 3. So I'm going to plug that into my equation. So I get y equals 3x squared. I always check my equation just to make sure it works. So I plug it in for a few other values that's not the one that I just used. So for instance, if I had negative 1 in here, negative 1 squared is 1. Negative 1 squared is 1. 1 times 3 is 3. I should get 3 as my output. Yes, that totally works. So this is my equation that works for that particular table. It's a quadratic. All right, let's try 2 more. Again, I have this table. I'm looking to see that my x values all increase by 1. Perfect. So let's look for a difference here. And I notice that I add 3 each time. So I have a common first difference, which means that this is linear. I'm doing repeated addition, I'm multiplying. So I'm taking x and multiplying it by something. So this is linear. So I know my equation is going to look like y equals mx plus b. So I'm going to take my common difference here, and I'm going to put that in where the m is, because that's my common difference. That is my rate of change. My rate of change goes in where my slope goes. So now I have y equals 3x plus b, and we've done this before. I'm going to take one of my ordered pairs. I picked 2, 7. 7 in for y, 2 in for x, and now I do the math here. I get 7 equals 6 plus b. Subtract 6 from both sides. I have b equals 1. So my equation is y equals 3x plus 1. I'm going to go back and try some other set of numbers besides this 2, 7 to make sure it works. I'll use 3, 10. 3 times 3 is 9. 9 plus 1 is 10. Yep, that works. So there's my equation. It was a linear equation. One more. Let's take a look at this table here. So when I look at these, I don't see a common difference here. Let's try a common ratio. 3 divided by 0.75 is 4. 12 divided by 3 is 4. Oh yes, so I have multiplying by 4 each time here. So there's a common ratio, which means this is exponential. I'm multiplying by the same thing over and over again, which means I'm using an exponent. So my equation is going to look like y equals a times b to the x power. We're going to use this common ratio as my b. Remember, I'm multiplying by b repeatedly, so it's b to the something power. So it's b to the something power. I'm doing 4, so it's 4 to the something power, whatever my x is. I'm going to now take one of my ordered pairs here and use them for x and y to figure out what a is. So I used 1 and 12, so I'm going to put 1 where my x is, 12 where my y is. 12 equals a to the times 4 to the first power. That's 12 equals a times 4. Divide both sides by 4, I get a equals 3. So I have 3 times 4 to the x power. Again, I'm going to go back and check it. And let's use this 248. 4 to the second power. 4 to the second power is 16. 16 times 3 is 48. So that totally works. Please make sure you check your equations. That's kind of a big deal. If it doesn't work in the table, it's really not going to be much help to you. So using either our first difference, our second difference, we don't use the second difference, we just use that to determine what kind of pattern it is, or our common ratio, to write an equation, whether it's linear, whether it's quadratic, or whether it is exponential.